Hey, Algebra 1, just a quick lesson here on solving with radical equations. It'll be a nice review of solving equations to start with, and we just have these radicals on top of it. So the idea is I want to get this whole thing right here all by itself. So to do that, we're going to subtract 10, just like you would if we were solving this anyway. So now I have the square root of 5r equals 5. Now to get rid of that square root, we're simply going to square both sides, right? Whatever I do to one side, I have to do to the other. So that end result is simply going to be 5r on the left-hand side, because this square and square root just cancel each other out. On the right-hand side, we got 25, because 5 times 5 is 25. Divide by 5, so r turns out to be regular old 5. Not too bad, I think. And the second one here, this square root is already by itself. Notice there's nothing extra like that plus 10 was in the last problem. So that means we're ready for the second step already, which is simply to square both sides. So I have x minus 7. That's kind of the nice thing, is this left-hand side will fix itself. 6 times 6 is 36, and we're going to add 7 to that. So x turns out to be 43. The next one, things are kind of mixed around, but remember the goal is to get this square root all by itself. Notice I did not highlight that negative sign. So I'm going to start by getting rid of the 8 by subtracting it. So now I have negative square root of c equals negative 2. And my next step, I'm going to treat this like it's negative 1. So divide out the negative 1. Now I have the square root of c equals positive 2. And you guessed it. Now we're going to go ahead and square both sides. So c turns out to be 4. C4. All right, so that gives us the gist of what's going on. So my second layer here, we just have a couple of extra things going on. But nothing is going to be different. Remember, the goal is I want to look for the square root, make sure that is by itself. And it is, so that means we're ready to square both sides. So 4 equals negative 5w minus 2. Add that 2 over. So negative 5w equals 6. Look at this. And the nice thing here is, in this little set of problems, we already realized that these don't have to be super fantastic, really nice numbers. Right. If I need to put this on the number line, maybe I rearrange it into 1 1/5 or negative 1.2. But since we're just solving, not necessary. Right, what we're doing right now is we're just training our eye. We want to make sure that that square root is by itself. It's not by itself, so let's get rid of the 27. The opposite of adding 27 is subtracting 27. So s over 4 minus 15, that's all into the square root. And then we're just going to subtract. We get 11 here. Now we're ready to square both sides. Oh, that's a good one. All right, I'm going to change this into an x right here because I keep thinking it's a 5. So x over 4 minus 15 equals 121. We're going to add 15 to that. So x over 4 equals 136. And right now we are dividing by 4. So what we're going to have to do is multiply by 4 on both sides. We got 136 times 4 be 544 as our final answer for that one. All right, and then I know what you're thinking, hey, the square root's already by itself, and this square root's already by itself. And this one looks super impressive, but hopefully after one step here, you're going to see that this might be some of the easiest type of problem I can give you, because both of these kind of clear themselves out. So just have d plus 7 equals 3d minus 1. Now, we've been doing this problem since September this year, Algebra 1, so I know you can handle it. Which way would you go? Which way would you go? I hope you would subtract the d over here to keep that positive. That's one thing that we try to do. Not that it matters in equations, but it sure makes life easier when we deal with inequalities. So while we're doing that, we're going to add the 1 to the other side. So 2d equals 8. Divide that 2 out, so d turns out to be 4. Right, so this is kind of that extra model here, and hopefully I left it for last year, but hopefully you see that it's actually one of the easiest problems we can have. Okay. So since it's kind of the easiest problem, these are both by themselves. So I'm going to go ahead and square both sides, and it's kind of a, if you will, a wasted step, because it just means I'm going to rewrite everything without those square roots. All right, and now you're thinking, wait a minute, this one's a little bit different, and it is, but all we're going to do is cross multiply. So some time ago, we also did that as well. So I get 3 times 4x plus 11 equals 9 times x is just 9x. All right, so since it started off as both covered by the square root, I just want to make sure we had to do something extra for this one. All right, so let's distribute. We got 12x plus 33 equals 9x. We got to subtract the 12x, right? I know it's going to make it negative, but this gets me to the step that I want to be where the x is by itself. So negative 3x divided by negative 3, x turns out to be negative 11, and then we're in pretty good shape. All right, so I leave you with one more here. It's already by itself, so you know the drill. Go ahead and square both sides. That makes life a little bit easier. 8 minus 2. I'm going to change them to x's. My computer doesn't want to cooperate this morning. So if I write anything else, it looks really, even for my handwriting, it looks extra sloppy. So I'm going to make it x's to make it a little bit easier. Which way you want to go? Maybe add the 2x. And, you know, while I'm doing that, I'm going to subtract the 5. So I should get 5x equals 3. You got it. Divide by 5. X turns out to be 3/5. All right, so that's how we're going to handle our radicals. So it gives us a nice review of just solving equations by themselves. Of course, we could put some inequalities in here, but that's what we got to do today.